All right, so today we're diving deep into cocktail party chemistry, their episode 13.
Synthetic marvels, total synthesis, and nanocarbon innovations. A mouthful, I know.
Yeah, but definitely a topic that piques the curiosity.
Ah.
5 fascinating factoids ahead of us.
Buckle up. We're about to see how human ingenuity can kind of like dance with the brilliance of chemistry.
I mean, it's incredible to think about. We're talking about recreating nature's complex molecules, molecule by molecule, and then like jumping to materials just one atom thick.
Mind-boggling.
Yeah.
And it's not just the discoveries themselves, but the ripple effect. A breakthrough in, say, total synthesis can spark innovations in areas you wouldn't even think of.
Okay, so total synthesis. Sounds pretty complicated. Like, are we building like microscopic Lego models here?
It is pretty complicated. Think of it like building a Swiss watch atom by atom.
Oh, wow.
You need a crazy deep understanding of molecular architecture, mastery of chemical reactions, and like superhuman patience.
Okay, so why bother?
The payoff is huge. Imagine recreating molecules found in nature, ones that took evolution millions of years to perfect, and using them to make new life-saving drugs.
Oh, I see. Like unlocking nature's pharmacy and writing our own prescriptions.
Exactly. Take Taxol, a powerful anti-cancer drug. It was originally extracted from the bark of the Pacific yew tree, but
Wait, really?
from a tree, yep. But synthesizing it in the lab made it much more accessible and even paved the way for making even more effective versions.
Okay, so from painstakingly recreating nature's blueprints to actually improving on them.
Yeah.
Amazing. But speaking of amazing, we go from this meticulous, planned world of total synthesis to something totally accidental nylon.
Ah, yes, nylon. Imagine the 1930s. A chemist is searching for a synthetic alternative to rubber, and boom, stumbles upon a brand new polymer, nylon.
Wow. It's like looking for copper and striking gold. But, I mean, what's so special about nylon? Besides, those snazzy stockings.
Yeah. Well, it revolutionized material science. Incredibly strong, lightweight, durable. It's used in everything. Clothing, parachutes, ropes, even toothbrush bristles. It really changed manufacturing and consumer products forever.
Wow, I never thought about nylon like that.
Yeah, and it fundamentally changed how we think about polymers, opened a whole world of possibilities for creating synthetic materials with specific properties.
So, classic serendipity. Now, let's switch gears from everyday materials to something a bit more otherworldly. Buckminster fullerenes. Now, that's a name, right? Sounds straight out of science fiction.
The structure is even more sci-fi. Imagine a soccer ball made entirely of carbon atoms.
A carbon soccer ball?
Yeah, 60 carbon atoms to be exact. That's a Buckminster fullerene, or a buckyball for short.
So it looks like something like nature wouldn't create on its own.
Exactly. Before buckyballs, we thought carbon only existed in a few basic forms: diamond, graphite, and amorphous carbon. But this crazy cage-like structure changed everything.
Wow. So it's like discovering a new element, but instead of a single atom, it's this complex symmetrical structure. What's so special about it?
Well, it's incredibly stable, can trap other atoms inside its cage, and has some cool electrical and optical properties.
Okay, hold on. Cool electrical and optical property.
Yeah, making them ideal for all sorts of things: drug delivery, medical imaging, electronics, even solar energy.
Wow, so it's like they took carbon, like the simple element, and turned it into like a microscopic Swiss Army knife.
It really is. Buckyballs were like opening the door to a whole new universe of materials. Scientists are like, wait, if we can make carbon do that, what else can we do?
Okay, yeah, so beyond the buckyball, what's out there?
Well, imagine stretching that soccer ball shape into a long, hollow tube, and you get
Tube-shaped soccer ball.
a carbon nanotube. They're crazy strong, like stronger than steel, and they conduct electricity amazingly well.
Stronger than steel? That's insane.
It is. We could be talking next-gen electronics, super efficient solar cells, all sorts of stuff.
So we're going from soccer balls to tubes. What else?
Okay, now take those buckyballs and fuse them together into a sheet, 1 atom thick.
Hold on. 1 atom thick. Are you serious?
Yeah. That's graphene.
That's like mind-blowing.
I know, right? And it's not just spin. It's also one of the strongest materials we know of. Conducts electricity better than copper. It's flexible and transparent.
Okay, so it's like the ultimate material. Strong, conductive, flexible, transparent. What can it do?
Well, there are still some challenges, like how to make a lot of it and how to work with it on a larger scale.
Ah, okay.
But think about it. Flexible electronics you can wear, or even implant. super efficient water filters, sensors that can detect things at the molecular level.
So like revolutionizing tons of industries.
Mhm.
And it all comes from this sheet of carbon atoms, just one atom thick.
Pretty incredible, right?
Yeah. So was this a total accident like nylon? Or did someone like set out to find this stuff?
It's a good question. There was definitely some chance involved, but it really came down to scientists being super curious about carbon. They wanted to understand how it could form all these different structures, how it bonds with itself in so many ways. That curiosity led to decades of research and exploring the potential of carbon to make these exotic materials.
So it wasn't just a random discovery. It was years of research driven by this passion for understanding, like the fundamental stuff of the universe.
Yeah.
That's really cool. What's the thing that excites you the most about all of this?
You know, it's the audacity. Humans have always been fascinated with creating, shaping the world around us, but now we're doing it at the atomic level. It's a whole new level of creation. We're designing from the ground up, atom by atom.
It's like we're becoming like architects of reality itself.
Exactly.
And this is just the beginning.
Right. Who knows what other crazy discoveries are waiting to be made?
What new materials, what new technologies are out there? What else can we do with this stuff?
That's the thing about science. It never ends. The more we learn, the more we realize how much more there is to learn.
That's so true. Well, that's it for our deep dive into cocktail party chemistry this time. I don't know about you, but I'm feeling pretty inspired.
It's wild, right? Like for centuries, people were obsessed with alchemy, turning one thing into another, and now we're actually doing it.
I know. It's like alchemy, but like with actual science.
Exactly. And we're creating these materials that like have properties we never even imagined before.
It's like science fiction becoming reality.
Right. So what other impossible things will we be able to do in the future? What other mysteries are waiting to be discovered?
Who knows? But it's exciting to think about. This whole deep dive into cocktail party chemistry has really been amazing. It shows how much potential there is when you mix human ingenuity with chemistry.
Totally agree. It's been a wild ride. Total synthesis, nylon, nanocarbons.
And that carbon soccer ball, the buckyball.
Right. Proof that the most groundbreaking discoveries can come in the most unexpected packages. Totally. So what stands out to you the most from all this?
I think it's the realization that we're not just watching the world anymore. We're actually shaping it, creating things that never existed before. That's a pretty powerful idea.
It really is. And it shows what humans can do when they're curious and creative.
Absolutely. We're not just observing the universe anymore. We're participating in it.
Exactly. This deep dive has shown us that chemistry is full of possibilities, and we're just scratching the surface. Synthesizing complex molecules, creating materials with amazing properties, there's no limit to what we can do.
And it's all thanks to the people who are out there pushing the boundaries of what we know, one atom at a time.
Well, to our listener, we hope you've enjoyed this deep dive into the world of synthetic marvels and nanocarbon innovations. We hope we've sparked your curiosity.
And remember, the journey of discovery never ends. Keep exploring, keep asking questions, and keep being amazed by the world around us.